good afternoon. My name is Paula Almiron. I'm the funding manager at EIT Food. I work for all the European regions. I'm part of a team that is responsible for the success of our partners and participants. And we are happy to have today partners from all the European regions and some startups. Today, we are going to have one startup that is going to pitch their solution. Is Chemometric Brain. Their CEO is going to be the speaker, is Jacob Christensen Ilan. Before Jacob takes the floor, I'm going to make a brief presentation of what we do at EIT Food. In the next sessions, we are going to have mission 1, that's healthier lives through food, and also mission 2 in September, a net zero food system. So for the ones that doesn't know much about EIT Food, we are the largest and most dynamic food innovation community. We focus on innovation to build a food system that produces healthy and sustainable food for all. We are supported by EIT, which stands for the European Institute of Technology and Innovation. This is an agency of the European Union. We concentrate on 3 main areas. We invest in projects, organizations, and entrepreneurs that share our goals. We unlock innovation potential in businesses and universities, and we help agri-food tech startups to bring new technologies and products to market. Most importantly, we put consumers and citizens at the heart of our work. We have currently 3 regional offices that operate through Europe. So you can see in the slide 3 different colors, purple, blue, and green. Those are the regions that are part of our community: Northeast, West, and also South. This is our community. As you may see, we have industry partners, startups, research centers, and universities. All of these organizations are part of what we call the knowledge triangle. Specifically, the knowledge triangle are universities, research centers, and the industry. Okay, and finally, I would like to just briefly refer to our 3 missions. These are the 3 pillars that organize all of our work. We have healthier lives through food, that's mission 1, net zero food systems, and the third one, the one that is gathering us today, is managing risk for a fair and resilient food system. In this last mission, we will see the benefits of more resilient, trusted food systems where people experience greater food security and safety through digitally enabled transparent supply chains. And this is the solution that Jacob is going to present today. Is absolutely aligned to this mission. So I think it's absolutely suitable. Okay, so before moving on, just to let you know that we are not only the largest innovation community, we also cover all the pillars that are key in our food systems. That's why we have activities that cover education, innovation, entrepreneurship, and public engagement. In the education area, we cover courses for the public, doctorate studies, master's studies, and recently we have incorporated training courses that are tailored for corporates. We also have the innovation area that has an open innovation call that is a flagship program that supports startups, industry, research centers, and universities that have an idea, a solution, a technology, something that should be researched or studied, and that aligns with our missions and is going to have a great impact in our society. Then we have the entrepreneurship space, where we have 3 flagship programs: the Seedbed Incubator, the Food Accelerator Network, and the Rising Food Stars, plus other programs and activities that are also aligned in this pillar. Finally, we have public engagement, and there I just want to highlight Food Unfolded. If you are on Instagram, just follow that account. It's incredible, the content that we have there. And we also have some other calls that I can share more information later on as they are open now. Just focusing on our webinar, we organized this series in 4 topics that we consider that are very important to present a startup for the audience. So the first one is to indicate what is the solution and the impact that this startup is providing. And when we talk about the impact, we're going to talk only about the impact of that technology, of that novel food, that specific impact, not the impact of the whole solution that a problem in the food system could have. The scalability of that solution, the barriers that that company has in order to enter to the market, and the barrier that the competitors have, and any opportunities for collaboration inside of EIT Food, but also outside of EIT Food. So now, Jacob, the floor is yours. Here you have my details. Well, those are my previous details. As I told you before, now I'm the funding manager for all the European regions, and you can contact me at my email if you need anything from my side. So I'm going to stop sharing. So Jacob, if you would like to take the floor.
Thank you so much, Paula. Thank you for having me here. And thank you to all the EIT team for making this happen. I will just shortly share my screen and introduce Chemometric Brain. Give me just a second. Okay. I can get this one here. Share. And you can now see my screen. You let me know when you can.
Yes.
See my screen?
It works.
Fantastic, fantastic. So it's a pleasure to be here and introducing Chemometric Brain. So Chemometric Brain is we are a software and services company providing services for the food industry for better quality control and faster decisions. Just as a little backstory to where we come from, we are actually a spin-off from a larger corporate entity, a company called BlendUp that is operating a global network of food production hubs on 4 continents around the model of decentralized food production. And we are born actually out of the need to have a system, a robust system for quality control across all of these continents, in which we can easily characterize, identify, and compare raw materials from all over the world. So what we're going to tell you today about the technology that we chose, the software and the solutions that we developed, and what we now provide to the entire food industry, it all comes from a long road of experience with real challenges in the industry. So without further ado, these are some of the problems that we really are looking to resolve. We see that raw materials, especially in the food industry, there are ever more unmitigated risks. We see all kinds of risks, from product changes that might be changes in origin, might be changes in variety, process changes that might come from the extraction process, the drying process. We see the humongous challenge of food fraud, a $50 billion a year problem that can go everything from adulteration, misrepresentation, substitution of the products. And then additionally, we see challenges with the existing quality control systems, which allow very little control over non-primary properties. So what is the current status of the food industry? What are the current systems and what are the blind spots? Well, this is what it typically looks like when it comes to raw materials in the food industry. There are some level of physical chemical inspections, typically for primary risks that are not on the certificate of analysis. And there's occasionally a confirmation of the certificate of analysis. In our opinion, this is far too little control for an industry that is highly vulnerable, that is an industry that has high volatility in prices, where there are a lot of risks that continue and remain uncontrolled under these existing systems. So when we look at a solution for this technology, already back in 2008, when we first started evaluating this technology inside of the company that we stem from, we looked at NIRS as a great solution. So for those that don't know the NIRS technology, this is near infrared spectroscopy. And this is a technology that allows us to get a unique spectrum or fingerprint out of any food product that contains a lot of the chemical information of the underlying product. And it allows us to capture this data instantly without any sample preparation. For those that have been into a laboratory, that have seen the quality control procedures, will know that sample preparation and capturing or getting results quickly is not the standard. Most methods for laboratory control, quality control, actually require long preparation. The challenge that we see, however, was that for a long time, NIRS was solely used for replacing traditional analysis. So it was a great way of actually saying, if you were doing Kiedel analysis for protein determination, you could replace it using NIRS. You could create certain models that will allow you to predict, just based on this spectrum, the protein content of the product. And that was great, but we saw much more potential in the technology. So we wanted to use this technology and saw the potential for it to resolve and detect issues that could come from product changes, process changes, fraud, non-priming proper changes, et cetera, et cetera, et cetera. There are so many things that technology could be done with, or that could be done with the technology, but currently weren't being done. So that's where we decided to develop a powerful spectra, or a powerful software for data analysis and processing. And today we offer this to the food industry without the requirement to be an expert. So today we have a team of experts behind the software. So not only do we offer the tool to interpret the data, process the data, and give you these insights, but also the team behind it that will allow any company to actually access this technology without the need to be an expert. One of our main goals, one of our key objectives, has been to really democratize the access to this technology. So as I was describing today, Chemometric Brain is the leading software for quality control based on NIRS technology. And we're solely focused on the food industry. I specify this because there are many applications for this technology, but we focus specifically on enabling the food industry with this technology. We work and we have integrated by decision with many different hardware manufacturers, which means we are hardware agnostic. And so we can work on any of the existing hardware platforms and extract all of these additional insights for customers that already have the technology, and work with new instruments to develop easier to use solutions. And sorry, I think there's somebody I can hear. That's right. And there's we've also created a very easy to use interface for everybody, from quality technicians to the data analyst modelers, to actually use this technology. And as I was mentioning, it's all supported by a team of experts that sits behind all of the technology. So what are some of the applications really? Let's talk about some of the practical applications of this technology. When we look at, for example, adulteration, one huge issue inside of the food industry, with our technology, we've actually got the potential to detect adulterations. For example, in this situation, milk protein adulterated with three-way protein, that by traditional analysis methods, for example, a Kiedel, a Dumas, you would actually struggle to identify, or you wouldn't identify the fact that there has been an adulteration because the protein levels would be correct. But with this technology, because we're looking at the entire fingerprint of the product, and we're comparing it against the historical record of that product, how the fingerprint of that product should look, we can quickly detect that adulterations have happened on a product anywhere all the way down to 1%. Typically, economically motivated adulteration is moving somewhere close to 10% and above. What you see here on the screen, just for a short explanation, very simply, is all of these individual dots are that historic of data of what a milk protein should actually look like. And what we do is we create, using certain data modeling techniques, we actually create a model that allows us to very simply describe the variability of that product, create what we call a region of confidence. And after that, when we evaluate new samples, like these red ones over here that are not conforming, we can instantly see that those don't fall within the accepted range of variability for a product. Another example of what happens in the food industry typically, and is invisible to a lot of the industry, is supplier switching. For example, we develop a lot of solutions where customers are able to detect when their suppliers for a blend, in this case a vegetable drink, is actually changing the origin of the raw materials. In this case, we have two areas of confidence. One's what that's being generated with maltodextrin supplier A. And actually, after a switch to maltodextrin supplier B, we saw that the samples started to actually fall outside of that initial area of confidence. And the customer, or our user, could actually ask their supplier, hey, what is being changing inside of my product? So all of a sudden, you've got a visibility to a series of changes that happen upstream from you that previously were completely impossible to analyze. Because when you're looking at these types of issues, the only way to really detect this is by doing a full analysis of the entire chemical fingerprint of the product. And without a technique like this could potentially go into production. And of course, your supplier is likely to have done some testing to ensure that it might work, but it could not scale well to your industrial process. It could cause issues in your production. And so for us, transparency and really visibility of the supply chain is key. And that's what we're offering with these types of solutions. Another example that happens a lot, and here we're talking about powder products in this case. And one thing just to mention as well that is important is that NIRS can actually be applied to any type of product. So we can work with solid, liquid, gel, powder samples. And one application that we've developed for the food industry, specifically the powder blending industry, everything from bakery to functional ingredients to sports shakes and so on. They have a real challenge with actually determining when the homogeneity of the product is reached. And what we've done with NIR is create a technique for actually determining very rapidly through an industrial validation, really what the ideal blending time when maximum homogeneity of a powder product is reached. So in this case, what you're seeing here, an example is an example of the same product blended at 4 different times and then sampled throughout with the NIR. We've sampled throughout the blend. So you can see that there's an area of confidence that is quite separate from each other, where the dots actually show a lot of variability. The individual samples show a lot of variability, and that's for 4 minutes. Then you have a red one for 6 minutes, and then you have a blue one for 8 minutes. What we can rapidly determine from this is that actually by blending 6 minutes, you've got the closest samples to each other, and hence the most reduced variability and the highest homogeneity actually of that product. The alternative really to this, which takes a few seconds really to perform the analysis and a few minutes to actually set the experiment up, would be to actually do a full final product preparation to give you some indication that the product is well distributed and compare those different samples at different times. This is saving enormous amounts of time really for customers. Another example here that we like to share is we've spoken about raw materials, we've spoken about the input side, we've spoken about now optimizing the blending time. But again, here, for example, is an example of a final product. In this case, it's a final product that includes it's a vitamin mix. And it's a vitamin mix in which our customer was interested in really determining rapidly conformity to the internal quality standards, where the concentrations or the differences between the two different blends, in this case, blend type A in dark green and type B in light green, are as low as differences in milligrams per 100 grams. You can clearly see, and our customer clearly gets feedback about when the samples have or don't conform to this type A. And that allows them quickly to make decisions about which samples can be released quickly and are falling into their specification, and which don't and require some additional analysis or production or reblending. So this is really another example of something that is via traditional laboratory analysis, very tough to determine really. You have to perform lengthy experiments and quite costly as well. And with this technology, you can actually perform very quick determination that the final blend, even in such low concentrations, are actually working correctly. Finally, what does this all mean? Because ultimately, one of the key aspects is, okay, what is this really? What kind of challenges or what kind of impact does this have on our users? So here's a really great example. One of our customers, a large functional solutions manufacturer, had an error in their production where an automatic line was loaded with some amount of pectin when it was supposed to be exclusively loaded with mono and diglycerides of fatty acids. This is an error that is by specification. Their specification determines protein range, minimum fat content, and maximum moisture content. And hence, it actually is an issue that would go undetected. So this issue would have gone to a customer, or this product, this incorrectly blended product with the incorrect formulation would have gone to a final product. And in this case, it affected 7 lots for a total of 3,500 kilograms and could have been blended in a 15% of a final product, right? The effect really of that economically is quite significant, as you can see. And it means that our customer is very quickly able to determine, as I showed you in the previous example with the vitamins, that their final blends are always conforming to their specifications, and they're avoiding any challenges or any issues with that might arise from errors in production. Just to show and go a little bit more into depth on going back on the development of all these models. When we work with customers to actually develop these, we start by actually capturing good samples of the raw materials or the final products. And that, as I mentioned, could be any type of format, the product. And then we include those samples into a qualitative model, as we call them, where we build that area of confidence. Once we've got that area of confidence, you can validate new samples, and really all that the final user needs to know is whether it's conforming or not conforming to the specification that they have determined. This, of course, makes it very interesting and very simple to use against other traditional methods or other more complicated methods for analysis. And that really is everything that I would like to present today. So I think that takes me a little bit to opening up and wanting to hear your questions. I know that my colleague Sara, that is the technical director, also joined us finally, Paula. So she'll be able to field some of the more technical questions, and everything around some of the other challenges that you had on the board. I would love to answer some more questions. So please let us know what we've left out, or what questions we can answer.
Thank you very much for your presentation, Jacob. I think it has been a brilliant introduction to your solution that is already brilliant. We have a couple of questions from sources. So the first one is, how many products do you have data for?
So in the last few years since we started working, we've collected really around 300 or more than 350,000 spectra that are individual samples that we have captured, and really we've developed models for more than 500. We've developed more than 500 models for individual products. So we've got a very broad range of products that we've had experience with, and I think that's one of the benefits of this very experienced team with this technology that we have. Sorry, Paula, I think I can't hear you.
And if I remember right from the conversation that we had with Sara, you can train your algorithm in 1 hour. Really
quite quickly, actually. It requires some human intervention, and I think that's where the experts like Sara come in. But really, the training is very quick, and especially for some of the more traditional applications, quantification. So today I talked all about qualification because it's really the unique solution that we have developed, where we are really standing out and giving and providing a new value to this technology. But the more traditional quantitative applications, we've even developed very efficient ways to retrain the algorithms with reduced or no need really for human intervention. That has been a great benefit to all our users.
Okay. Then we have another question from Georgios. What depth can your NIR detect in food products?
I know that Sara's here, so maybe Sara, you can just answer a little bit. I know that NIR penetrates a lot deeper than other techniques in terms of spectroscopy techniques, but Sara, maybe you can provide some more info to that.
Yeah, in that case, the question is that normally the depth of the laser, how it's penetrated into the sample, it's in most of the cases related to the near device you are querying. So basically, it should depend, but the important thing here is that you have a higher powder than, for example, a higher powder of penetration than when you work with medium infrared. So for that reason is why you can work with any format. You can measure directly the product as it comes. So basically, this is the important thing. And of course, if you are working with, for example, a benchtop device, normally you can penetrate inside the sample, but also you can do with a handheld one. So basically, depending on the application, we normally advise the customer to acquire one handheld device or a benchtop device.
And this is very interesting because ultimately it makes the technology a lot more flexible, really, in how you can actually use it for any type of product, for detecting issues that not only are surface level, so you can really get a lot more information. And what Sara is, of course, describing is our ability to really work with any type of instrument. So we wanted to add additional flexibility so that it's all about the solutions always for the customer, and not so much the instrument. This is perhaps an industry that has been stagnant and developing slowly because of the hardware focus. And we've always been very set on delivering solutions for the industry, because especially in an industry like the food industry, where we're always under pressure to deliver, we're always under pressure by thin margins and changing supply chains. It's not like the pharma industry where we have the luxury of having an expert or many experts to develop and retrial and research. We need solutions that are going to work and are going to work now. And that's what we are delivering for the industry.
Do we have questions from the audience? Okay, just to clarify to the ones that don't know what the NIRS is, it's like a scanner, but that has like a door, like a tunnel, where you can put food and it's going to analyze at a certain point the components of that food ingredient or of that food. And what they have done is to further develop the knowledge that machine, the NIRS, could gain from that inspection, that the scan that it does. Okay.
Correct. I see Georges is also asking if we have our own NIR equipment. No, precisely, we've actually stayed away from doing NIR. I think there are so many great hardware in the market. There are a lot of bright people working on the hardware. So we decided to really focus on next layers, on the software layer and the solutions layer. That's why we're working not only on, of course, creating the platform that connects to many different instruments, and we're working with different instruments. So that helps, for example, companies that might be working with different brands of NIR actually harmonize and utilize the same software for multiple instruments. But we're also on the other side connecting with a lot of centers, groups, laboratories that are actually also developing solutions. So our goal is really to ultimately make much easier connection of everybody that has a lot of experience and know-how and access to samples for specific food products, so that they can transfer all of that knowledge into models for NIR, and those can actually be delivered for the entire industry to be used without them having to develop their own. Because up to now, there's been a lot of custom developments in those segments where there wasn't a huge market, and then there's been some specific markets where the hardware manufacturers have delivered solutions. You ask about Iris as well. Yeah, absolutely. We have worked with Iris. We've tested some of their instruments as well. We've had them. They are based out of Barcelona, and yeah, we certainly have.
Okay, thank you so much, Jacob and Sarah. I just want to ask you, which are the possibilities for collaboration that you may see in our EIT Food community or in general, just to know which are the future developments that you're planning.
Absolutely. We would love, like I was mentioning before, we are very keen on connecting with laboratories and technology centers that have an interest in really coming together with us on this road of really democratizing NIR technology. We think it is an unbelievably powerful technology for actually creating transparency in the food industry. We think that it is a tool that allows many more touch points than any other quality system has done before. And these are quality touch points directly onto the product. So these are real quality control tools, not so much other process-based or procedure or QA techniques. So we're testing really on the product. And so we would be very happy to connect, and are always looking to connect really with technology centers and laboratories that want to work together with us on the development of models for specific products that they have a lot of know-how around.
Okay, thank you very much. So I will ask again if we have any other questions. Okay, so we're going to finalize the session today. We will have another session in July. And I will share some, some additional information later on, and also the recording. So thank you very much. Have a nice afternoon.
Thank you, Paula. Have a great day, and thank you everybody for attending.
Thank you.
Thank you.
If you have any
Bye-bye.
questions, you let us know.